Recording in progress.
Yeah, comes on everyone. Let's start off. Let's keep the program very simple. Like I said, you should revise your notes and come. Right. I will try to cover up the concepts and different models using problems only. That's the best way to do it. If there is some concept to be taught, then I'll teach you. But let's go ahead. I already wrote down some questions beforehand so that we can save time in writing questions. Let's start. So first question say we have two charges plus q, both are fixed. There's a point charge in the middle, plus q and small m. It is displaced by x along the line joining the charges. Find the time period for small oscillations. Second question, we have three charges A, B, C, Q, minus 2Q, 3Q. Coordinates are given. Find the force on charge A due to B and C. So the format will be this. So you have a question here. So in the next page, I'm going to write the solution. So this will become your formula book also. So next time when you want to revise electrostatics, right, you can simply take out this and use this thing like a Viva. I hope the first question is clear. We have two charges plus q and plus q. You kept a charge small q and mass m at the center and you displaced it along the line joining them. Find the time period for small oscillations. And others do keep your cams on. It's in Coulomb's law and SHM. You got an answer? You can type in the chat box here to the co-host. If you're done, go ahead with the second one. The first question, right? If it is a minus q charge, then I can displace it up and down. That itself is another question. If it is a plus q charge, if I displace it vertically, what kind of equilibrium is this? If I displace horizontally, what kind of equilibrium is this? When you have a plus q, right, if you displace it up and down, it is actually unstable equilibrium. So we can discuss more on that. So when you have a plus q charge, the vertical direction will be unstable equilibrium. Because if you displace the particle in the vertical direction, it will just go away, it will never come back. But if you displace this in the horizontal direction, this is a stable equilibrium. So the same point can be stable or unstable equilibrium depending on which way you're displacing it. If it had been a minus q charge, then the vertical will be stable and the horizontal will be unstable. I hope you guys remember what is stable and unstable equilibrium. Right? In case you forgot, you should go back to work per energy and revise that. So how do we solve this? So plus Q, let thing be displaced by small x. Then this plus Q is pushing with what force? K, Q by d by 2 minus x whole square. This guy is pushing with the force of K, Q by d by 2 plus x whole square. And the acceleration will be this way. So Q 1 by d by 2 plus x whole square minus 1 by d by 2 minus x whole square, that is a net force, is equal to mass into acceleration. Take a d by 2 common, and since x is very, very small, you can do binomial approximation. This will become Q by d square by 4. And this guy will become, when it goes up, it will be 1 minus 2x by d minus 1 plus 2x by d. I hope you remember binomial approximation. When you have 1 plus x whole power n is approximately equal to 1 plus nx when x is much, much less than 1. So that when you take out d by 2 common, it becomes very small there. And then you can simplify this. You will end up with 4 Q by d cube. That will become 8. That will become m with a minus sign is equal to acceleration. This is your omega square. Time period is 2 pi by omega. Check. Clear with this thing. For small oscillations, it is an SHM. So this thing they can play in two ways. They can ask you in terms of stable and unstable equilibriums, or they can play with oscillations. I can displace this in the vertical direction. That also will give you a time period if it is a minus q charge. Clear with that? What about the second one? Find the force on A due to B and C.
We have to use the vector form.
Yeah, you have to get the vector form. So if you take the 3 points there, you want the force on A due to B and C. So this is A, this is B, and this is C. Okay. So C के place में we have 3Q, and this thing is minus 2Q. So this guy is going to repel. This will be force on A due to C. This is going to attract. This is force on B due to C. And if you look at the vector forms, right? I will write the vector form also. This is FAC into AC cap. This is FBC into, this will be AB, this is FAB, AB cap. The vector is going from A to B. This vector is going from C to A. So this is CA cap. There, that's your vector form. So Coulomb's law, you will get the magnitude from there. So you can find FAC. FAC will be K, Q, 3Q, distance between A and C. Then that you can get the coordinates. 1 minus 3 root over 1 minus 3 is 2 square, 2 minus 1, 1 square, 3 minus 2, 1 square. And the vector form, CA cap. You know how to find CA cap. Similarly, the force between A to B, K, Q, 2Q. Again, I'm taking the magnitude here, so you can ignore the minus sign. And the distance will be A to B, right? So 1 minus 1, that is 2 square, 2 minus 1, 3 square, that is 5 square, and the vector will be AB cap. There, add both of them, you'll get the answer. Clear with this? So get the magnitude and get the vector form. Minus sign, so it will be, attracting, plus it will be repelling, and then you're done. You know how to find caps vector, so I'm not going to do that. Next one. We have two charges, so don't worry about writing, you will get this anyway. So this is what is there, the question is there. So next time you want to revise this, you can have the questions here, you can try it for a minute or two. So it's like your Viva basically. Instead of someone is asking you, you have it in the questions, and then you have the solutions in the next page. So we have two pendulums, charge Q, density rho B, vacuum L and L. The angles are 60 degrees. When you take these two, then just take the system and put it inside a liquid of density rho L and dielectric constant K is equal to 2, the angle still remains same. Find the density of the liquid. Find the density of the liquid if the angle between them remains same even after immersing in the liquid. Gravity is there. System is in equilibrium. Right there, yeah. Someone not clear with the question, please ask. So you need to ask yourself, when you put something inside a liquid, what happens? In Coulomb's law, the force decreases, but something else also happens. I combined two different chapters though. Two क्या? Two what रे Kritik? Right answer. See. So initially, draw the free body diagram. What are the forces acting on them? You have your weight mg, which is nothing but rho body volume g, the repulsion force, which is F, and your tension T. This angle is 60 degrees. So tan 60 will be the opposite side, which is F by mg. Right, and F is nothing but K Q square by D square, where D is the distance between them. Luckily here, distance didn't change. I could have made the angles 30 and 30. That would have been actually a little more tougher, but I didn't change that angle. So the catch is this. What changed? The force becomes F by K. You guys remember that? Whenever you put two charges inside a medium, the net force on the charge becomes 1 by K times dielectric constant. The gravity remains the same mg, but now you got a buoyant force. Because you immerse the body in a liquid, there will be a buoyant force, which is rho liquid Vg. That was a catch in the question. For some reason, the angle still didn't change. So the horizontal force will be F by K, and the vertical force will be mg minus Fb, and the angle still remained 60 degrees. So tan 60 will be F by K, which is F by 2, and this will be mg, which is rho body volume g minus buoyant force rho liquid volume g. So that this equation and this equation are equal. So I actually don't need F ka value also. So if you equate them, you end up with F by rho B Vg is equal to F by 2 rho B minus rho L volume G. F goes off, Vg goes off. You are stuck with rho B is equal to 2 rho B minus 2 rho L. So rho liquid will be rho body by 2, half of the density. Clear with that? Yeah, I think now most of you got it. So the catch in the question was that when you immerse the two charges in a medium, the force decreases. The mg also decreases because mg doesn't decrease, but in the vertical direction, the force decreases because of the bind force. Clear with this? Fluid mechanics, Coulomb's law. There, this much level you should learn. Don't look at your mains ka PYQs and become happy. Your mains ka PYQs are very deceiving. They will give you a feeling like हाँ सब हो जाएगा. Exam में you will find this kind of questions and you will get trapped. Let's get this thing. 3 questions. We have 2 charges Q1, Q2. Find Q1 by Q2. There are electric field lines here. Compare electric field and potential at A and B. There are 2 charges minus Q plus Q. Plot electric field on the x-axis versus x coordinate. We have done these questions in the class notes. V is the potential, E is the electric field. Get them. Ex is the electric field on the x-axis. So if a person is walking on the x-axis, he will experience an electric field. You need to plot that electric field versus x coordinate. Get them. Decent questions. Finish all three, then you can answer together. Don't worry about answering, finish it off, finish all solving. Because I'll not give you more than 2 minutes for this. I'll just keep moving around. My main thing is to get you exposed to as many questions as possible and to make you remember how much you forgot. If you got everything, then great. You remember, then you're confident you remembered most of the stuff. So you just finish it off, and once I tell you the answers, you can check whether you got it right or not. Let's see. We should be able to do at least 40 to 50 questions. And if you see, this is actually 3 questions, right? I kept it in 1, but okay. What is the point, na? If you're sitting with me for 2.5, 3 hours, if you're not even doing 50 questions, then it's a waste of time. Another 30, 40 seconds. Let's see. First thing, how do you find the charges in this thing? You count the number of field lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you remember, the number of field lines coming from a charge is proportional to the charge. If more charge, more field lines will come out, isn't it? So here you can clearly see Q1, 14 lines are coming out. So that's plus 14. Q2, 10 lines are going inside. It's actually minus 10. So this is actually a ratio of 7:-5. The Q2 charge is negative. Lines are entering Q2 and lines are leaving from this thing. So there'll be 2 options, 7/5 and minus 7/5. So be careful. You have to mark minus 7/5. Second thing, if you guys remember, in the direction of electric field, potential decreases. That is what the minus sign indicates in the formula. VA minus VB So if you remember, VA minus VB is equal to minus integral E dot dl. So in the direction of E bar, potential decreases. Quite an important thing. And what is electric field? A number of field lines per unit area. If you have more field lines per unit area, then the field is more. So you can clearly see at B, the concentration of field lines is more. So field at B is greater than A. But in the direction of field lines, potential will decrease. So VA is greater than VB. Are you clear with that? If you travel along the field lines, potential should drop. So VA is greater than VB. But B pay, there are more lines per unit area. So EA is greater than EB. And how does this graph look like? If you remember in the class note, go and check it out. There is a minus 4Q and 4Q ka graph. That was the most deadly graph. So minus Q plus Q. These questions are important because I can ask these questions in gravitation and also in magnetism. So what does this minus Q do? Look at this thing. Minus Q will attract the field on the left hand side, will attract like this on the right hand side. This is plus Q, no? Yeah. This guy will repel here, will guy repel here. Great. So ask yourself, if you're standing at infinity, what is the field? Zero, right? Now, as you get closer here, if you're standing here, you will experience field is which way? This side, right side, because minus Q is attracting. So right is positive, left is negative. That means your field is going in the I cap direction. So as you get closer and closer to the charge, the field will keep increasing in magnitude and it is always pointing to the right hand side. The field will go to infinity when you get close to the charge. Are you clear with the meaning of the graph? So two things here. What is the direction? What is the magnitude? If you get closer to the charge, field ka value will go to infinity. Right? If you go away from the charge, value will decrease. When you're standing on the left hand side here for the minus Q, it is attracting. So the field is on the I cap going to infinity. Once you cross the charge, the value is still infinity, but now it is attracting to the left hand side. So that means the field will go from here, and be careful, there will be no null point here. Minus Q and plus Q will not cancel in the center. The field actually adds up in the center. So the graph will be like this. And once you cross this, you can clearly see the field is still acting on the left hand side, minus I cap. So the negative graph indicates field is minus I cap, plus I indicates field is in this thing. Will go down again, goes to infinity again. And once you cross this, the field is infinity from plus to this. This is how the graph looks. Clear with this? So whenever you get closer to the charge, you'll blow off to infinity. The only thing you need to check, am I on the left hand side, right hand side, what is the direction? And are there any null points in the graph? So generally, eliminating graphs is easy. That is what you do in the exam, right? Drawing the whole thing is actually difficult. And if you do for 4Q and minus Q, you'll get even a more beautiful graph. You should definitely check out the notes. You will see that later on. Let's get this. Two masses, m and 2m. 2m is fixed. And initially, they're very far. Second case, m and 2m. 2m is free to move. And the other particle is projected with speed u. Find the minimum distance between them. Both are plus q charge, so they will repel as they get closer. In the first case, the 2m is fixed. In the second case, 2m is free to move. Find the minimum distance between the particles. Everyone should try. It's fine if you don't get it. That is what you're trying to do. You are learning here. In case you don't get it, that is fine, but try. Means out of 25 questions, there'll be at least 20 questions which you must have seen before. They're not going to ask you something really out of the world. The only reason why people slow down in the mains exam is because you didn't get exposed to enough variety or you didn't solve enough material. Yeah, we always neglect gravity whenever there's an electrostatic force until unless it's mentioned. You don't take gravitational force between them, right? That will be 10 power minus 20 times less, remember? First was easy. Initially, you're very far. Then, when you come very close, you will stop eventually because you're repelling. Let the distance be d. This is your initial state. This is your final state. Initially, kinetic energy, half mu square. So, initial energy is equal to final energy. There are no work done by external forces. Can I conserve momentum in this case? Why cannot I conserve momentum? That itself is a question. Can I conserve momentum in this game? You cannot conserve momentum. Why? Because this 2m is fixed. That means there is an external force which is keeping 2m at rest, isn't it? Someone is holding it. So linear momentum is not conserved. But if there is a force on the system, how can you conserve energy? If there is a force on the system, how can you conserve energy? I'm trapping you guys. Socho, to conserve energy, should force be zero or work must be zero? Work must be zero, na? Even though there is a force on the body, the displacement of the body is zero. Are you getting it? Since that body is not moving, displacement is zero. So work done is zero. Therefore, energy can be conserved, but not linear momentum. Are you clear with that? There is no work done only, na Rachel? What will be heat? You are just holding this. Someone is just holding it. What is work done by force? Force into displacement. Displacement of what? Displacement of the body where you are applying the force. Clear with that? So that would be a good theoretical question. Huh? In this case, so don't just only think about the question. They can really play around. Linear momentum is not conserved. Since F external is not a zero, since 2m is fixed, someone is catching 2m. That's why you're not moving. Energy is conserved because work done is zero, since displacement is zero. Don't see the displacement of m. We are looking at the displacement of 2m. Right? So then this is easy actually. So this will be half mu square, and the final kinetic energy will be zero. Initial potential energy will be zero because you are very far. This will be equal to k q square by d. That's it. You get this, you'll get the answer from here. That was an easy one. Second one is still good. What about this guy? Here you can conserve both momentum and energy. Yeah. We can use reduced mass. Yeah. A problem with that, if suppose if they're not on the same line, then you can't use reduced mass. So how do you do it normally? Reduced mass is fine. So when you're very far, what is the energy here? So initial energy will be half mu square. That's it. There is no thing. And finally, when there's a minimum distance between them, both will have same velocity. Hope you remember this. This question is similar to having the block and the spring wala problem. Yeah, this thing is given you, find the maximum compression in the spring. And we use the formula here, half k x max square is equal to half mu v relative square. Mu is the reduced mass. You can actually use something like that here also. But first let me show you the normal one and then I'll show you that also. So at minimum distance, they have same velocity. So then you can conserve momentum. M into U is equal to 3m into Vc. Vc is equal to U by 3. This is also actually the velocity of center of mass. Then your final energy will be half 3m V common square. That's your kinetic energy plus potential energy will be kq square by d minimum. There, E1 is equal to E2. You'll get your answer. Now, if you want to use reduced mass here, same idea. Instead of half k x max square, the potential energy will be kq square by d minimum. That is acting like a spring there. That must be equal to half mu v relative square. You get the same answer. If you can remember that in the exam, great. But always know how to do, even if it takes little more time. There you can conserve momentum and energy in this thing. Both will work. All clear with this? Let's get this thing. We have 3 charges on an equilateral triangle, 4 charges actually. 3 on the sides and 1 in the centroid. Someone converted this into a square. Find the work done. Second question, we have infinite charges plus q minus q plus q minus q at a distance of a, 2a, 3a, 4a, so on. Find the potential at the origin. We have a rod here at a distance d. Find the electric field and potential at point P. Get them. Just write the equation and leave it. Simplifying, you can handle that much later on. Just write the main equation and you can leave it there. Don't worry about getting the answer till the last. That much you can handle it. I trust your calculations. Even if I don't trust, the speed test will take care of that. Most of you are getting it. So what about the first one? What is the initial potential energy? This is the initial potential energy. Remember, the potential energy of a system is potential energy of all possible pairs. There are 4 charges here. You have to select 2 of them, 4C2, isn't it? That will be around 6 pairs. So we have 3 centroid pairs and 3 side pairs, isn't it? You have to take the all possible combinations there. So this will be 3 times k q square by a. These are the sides. Plus 3 times k q square by the distance from here to centroid will be what? It will divide in the ratio of 2:1. So that will be 2/3 of root 3 a by 2. That is a by root 3. So this is with the centroid, the vertices and the centroid, total 6 pairs. Here, 4 sides and 2 diagonals. The u final will be 4 times k q square by a plus 2 times k q square by root 2a. So these are the sides and this is the diagonals. So the work done is simply u final minus u external. Subtract them, you'll get the answer. Clear? So 4C2, there are that many pairs, you have to be careful. What about the potential here? KQ by A, if you take out that common, you'll end up with 1 minus half plus 1 by 3 minus 1 by 4 and so on till infinity. If you guys remember, this is a ln 2 ka series. Ln 1 plus x, where x is equal to 1 ka series is that. So most people, right, they don't understand how you got the ln. So you need to know it's a ln ka series. So not a tough one. Like I said, the point is not to give you very tough ones, and out of that, we will do in advance. For now, it is to clear up as many things as possible, small ones, little different ones. What about this guy? This is a little integration. Get this, I'll give you a minute more. Potential and field both. Let's go solve, everyone, focus. I'll give you a 10-minute break in the middle somewhere. Yeah. So how do we do this thing? At a distance x, take a small piece dx. So the small piece dx will have a charge dq is equal to lambda into dx. So the electric field will be integral k dq, that will be lambda dx by x square. And what are the limits? So this x, right, is a distance from point P. So the limits will go from d to L plus d. Agreed? So if you take x is equal to d, you're choosing this point in this corner, rightmost corner. If you take L plus d, you're choosing the leftmost corner. So when x ka value goes from d to L plus d, you're covering the entire rod. So this will be k lambda dx by x square d to L plus d. You know how to solve this. I'll leave it. We can finish off this actually. Minus k lambda, that will be 1 by x, so 1 by L plus d by 1 by d. What about potential? Same thing, but the formula will be k dq by x. This will be k lambda ln L plus d by d. You'll get dx by x. Clear? Same question I can ask you in gravitation also. So whatever I'm asking you, you can do the same thing in gravitation, right? K becomes capital G. What about this one? Let's change this into this question. Wait. So we have a particle here, mass m. This is a solid sphere, mass m, radius r. So you have a solid sphere with a tunnel. So a particle is dropped from the released from rest here from the surface. Find the time taken to go from A to C. C is the center. A is a point at a distance of r by 2. And find the speed at point A. I am not asking you time taken to reach the center. I'm asking you time taken to go from A to C when you release from the surface. You need to find the T also, right, Aditya? There are two ways you can, for the time, you have to use SHM. There is no other way. So you can actually completely use SHM and finish off this. We have to use little gravitation ka formulas though. T by is x2 by, right, Yashul? I think so, that looks right. T by 6, yeah? I don't think it is T by 6, right? So how do we do this? See. So when this particle is falling here, let's say at a distance x, what are the forces acting on the particle? The force acting on the particle will be g m small m x by r cube. Hope you remember, right? The field into this thing. This will be the force on the particle. I'll write like this, but m into E, where E is the field, which is m into g m x by r cube. So we get force is equal to g mmx by r cube is equal to minus mass into acceleration. So we get acceleration is equal to minus g m by r cube into x. So therefore, this is actually doing an SHM, which is 2 pi root over r cube by gm. This is your omega square. Now, if you're releasing it from rest, right? At this point, if you're releasing from rest, that's an extreme position, isn't it? So your whole equation has become like this. X is equal to 0, that is your center. X is equal to r, you're releasing from rest. So this is your extreme position. And you're saying there is a point A somewhere here, which is at x is equal to r by 2. What's the time taken to go from r by 2 to 0? T by 12. Remember? How do we get that? In case you forgot, I taught you this also. Think of like this. What is r by 2? Sine theta is half, isn't it? So you can simply write sine omega t is equal to half. That means omega t must be 30 degrees. That is 2 pi by capital T is equal to pi by 6. So we'll get t is equal to pi by, capital T by 12. You should check out SHM in case you want to do that. So you're done. So time taken to go from A to C will be T by 12. And what is the speed at the center? Speed at the center is the maximum speed. And what is the maximum speed in SHM? Amplitude into omega. And what is amplitude? Radius. Omega, you know already. Take it and substitute here. Clear with that? Now in this, if you guys remember, we did this tunnel questions also. What if someone digs a tunnel like this? At a distance d. Then you release a particle m released from rest here. And Let's say this is distance x. Plot normal reaction on the wall versus x. So as this particle is sliding inside, it will start pushing the wall. Plot the normal reaction versus on the wall of the tunnel versus x, where x is the distance from the center of the tunnel. And d is the distance of this thing here. I can ask you time period also, but I hope you remember that time period remains same. Independent of where you dig the tunnel, time period is independent of the d distance. The normal reaction is a good question though. Hmm. Right, Vihan. Right, so if you do remember. Yep. It's constant. So when you dig the tunnel like this, let's say when the particle is here, what are the forces acting on this? The attraction force will be towards the center. The normal reaction will be this way. Let the distance be x, let the distance be d, and let this distance be r. And let this angle be theta. And this force of attraction be F. So we can clearly see N is equal to F sine theta. And what is F? F is G M small r by r cube, that's your field, into mass, that is your force, into sine theta. Sine theta is again x by sine cos theta, sine theta. Wait, I wrote wrong. Now this is d and that is x. I was wondering why I'm getting such a weird answer. D by r. Small r will cancel. You end up with g small m d by r cube. Check it out. Constant. The normal reaction does not change. So as you're grazing the tunnel, you'll have a constant normal reaction. So I can put a friction now mu and I can ask you then. Questions will completely change. Then I can ask you find the speed when it reaches the center of this thing. Now you can't conserve energy. You have to take the work done by friction also. Getting it? So you can make it questions like that also. You can make it even better. And if you look at the vertical forces, that will be F cos theta is equal to ma. So this would be minus g m m x by r cube is equal to ma. You still get the same time period. So it doesn't matter where you make it. The time period is 2 pi root over r cube by gm. Remember the result. It's quite important. Doesn't matter where you make the tunnel. The time period, again, remember it's the time period to go down and come back, full oscillation. Time period is independent of d. You can dig the tunnel wherever you want. Clear with that? So if that is the case, what if someone digs a tunnel like this? You dig a tunnel till here, and then you make a tunnel like this, and then you make a tunnel like this. Assume the edges are, these corners are smooth, okay? There is no collision. It will just glide and go. This is your center. X is equal to 0. Let's say this is x is equal to r by 2 and this is x is equal to minus r by 2. Now if you release a particle from here, A, B, C, D, and E. Find the time taken to go from A to E. Assume this corners are, the tunnel is smooth and the corners there's no collision. The particle will just glide. T/4. You can split this thing into 4 pieces, right? So this AB tunnel was actually this. So this was A and this was B. You're not completing the whole journey. You're only taking a part of it. This should be how much? T/4. Plus. If this was the full tunnel, you're going from B to D, which is R/2 to minus R/2. This will be T/6 till the center and T/6 from center to here. This will be T/3. This is from B to D. Similarly, DE also will be same. So this will be also equal to TDE. Therefore, the total time will be T/4, T/3, and then T/4. Agreed? If that AB had been a full tunnel, the time is T, but AB is only 1/4 of the total journey. Clear how to do that? So split each tunnel into one, chord and then get the times from there. Clear with this? You can play like this with the tunnels. Normal reaction, a lot of things there. Any doubts on this? Can you give me the formula here? This formula is very important. I told you this multiple times. If you have a solid sphere, mass and radius r, can you give me the field and the potential ka formula inside and outside? Especially the potential ka formula is important. Just write the formula. Find the potential and the field ka formula inside and outside. Solid sphere, mass and radius r. T by, sorry, this is T/12. That should be T/6. You're right. Yeah. Done. The formula shouldn't take more than that much time. So what is the field ka formula? Minus gmx by, or I'll take small r. Small r is the distance from the center by r cube. Outside will be minus gm by r square. This is for r less than r greater than equal to r. The graph is also important. Remember, this is a negative sign, so the graph will be actually below. It will be like this and then decays. The potential ka formula will be minus gm by 2r cube 3r square minus small r square. Most messed up formula. So definitely mug it up. There have been questions, where they asked you this result only directly. Minus gm by r. And how does the graph look like? If you plot v versus r graph, and again, potential at the center is not 0. For some reason, people say it is 0. Be careful. Minus 3gm by 2r. If it is a charge, then it will be 3kq by 2r. So the graph, if you see, the starting point is actually a parabola. The value starts from here. It will be like this. Then it decays. So the starting part of the graph is actually parabolic. Clear with that? All clear with this? So if that is the case, let's do a problem on this. So let's say we got a sphere, but here the charge density is different. Rho is equal to rho naught into 3 by 4 minus r by capital R. This is for r less than r, and it is 0 for r greater than r. This is your volume charge density, solid sphere. Plot electric field versus R graph. Let's get this. It's a good one. Variable charge density. If it is an exam, so I would have asked you find the point where the electric field is maximum. That would be a good one, but if you plot the graph, that is taken care of. Graph will be more deadly. Plot E versus R graph. Solid sphere with a non-uniform charge distribution. Gauss law, everyone. So focus, don't get tired. You can't get tired in 1 hour. How do we start this? Within first minute, you should have got an idea like how to handle this and what are the steps. Consider a Gaussian surface. Let the distance be some x. Distance r. This will involve little work. Now in this sphere of r, the thing is, first of all, I need to find the charge inside. At a distance x, if you take a thin shell of thickness dx, the charge dq will be rho into volume, which is rho naught 3 by 4 minus x by r into volume will be 4 pi x square dx. That is a volume of the thin shell. This is the charge on the thin shell. So q will be integral rho 4 pi integral 3 by 4 x square dx minus x cube dx by r. Limits will go from 0 to r. This turns out to be rho naught 4 pi. That will be 3 by 4 r cube by 3. 3 goes off. That will be r cube by 4 minus this will be r power 4 by 4r. What is this exactly? This is the charge up to small r. You're getting it? This is the charge in a solid sphere of radius small r, where r is less than capital R. Solid sphere up to r. So you first of all, your charge itself is not constant. Are you getting it? Clear with the step, everyone. First, you need to find how much charge is there within that red colored sphere. So once you got this, then I can apply Gauss law. Now this is for r less than r. Integral E dot ds is equal to q enclosed by epsilon. It's a sphere, symmetry E, and the surface area will be 4 pi small r square. Q enclosed will be this guy, which is rho naught 4 pi r cube by 4 minus r power 4 by 4 r. 4 pi goes off, 1 r square also goes off. You end up with E naught is equal to, take out that 4 common, that will be r minus r square by r. This is your electric field as function of r. And for r greater than equal to r, we have to, the total charge will be q total. When you put r is equal to capital R, that comes out to be r cube by 4 0 actually. Interesting. If you put r is equal to capital R, that's r cube by 4, and yeah, you're getting 0. So electric field outside is 0. Clear with that? So I want the graph now. So first of all, I need to find the maximum value also. This is a parabolic function. So for maxima, dE by dr is equal to 0. That would be 1 minus 2r by capital R is equal to 0. We get r is equal to r by 2. Perfect. So if I plot the graph, this is how it looks. When r is equal to 0, field is 0. So this graph is actually increasing. And then again, it should become 0 here. It's a neat parabola actually. This is your maximum value, which will occur at the r right. Clear with this? Is the concept clear, everyone? Outside it became 0. I gave good numbers. Then we can play around like this. So that's one good question. Any doubts on this? This is how they'll ask you non-uniform things. So be careful with that. Now, using this, can you give me the formulas for this? Finite line charge. What is the electric field formula? Arc formula for the electric field. These are again some standard results which we have derived. Ring. Find the electric field on the axial line. Get me the results. Anytime you think you forgot, that's fine. Make a note of it, revise the notes. Go back to the notes, you will learn. Forgetting is not a problem. After realizing you forgot, what did you do? Finite line ka formula. That's important. Let's see, what is the result? So this is how you write down the result. K lambda by D, right? Sine theta 1 plus sine theta 2 away from the wire. The other one, we know it is perpendicular, but if it's a perpendicular, it gets confusing. So write like this, K lambda by D cos theta 1 minus cos theta 2 in the direction of theta 1. Because suppose if someone gives a wire like this, then who is theta 1 and who is theta 2? You can choose anything as theta 1, anything as theta 2. So this guy is towards theta 1. In case of gravitation, it will be reverse. It will be opposite of theta 1 and towards the wire. What is the formula for an arc? 2k lambda by r sine theta by 2. Direct question, huh? They gave a semicircle and they asked to find the field at the center. So put theta is equal to pi. You will get 2k lambda by r. What about this guy? The electric field will be kq x by r square plus x square whole power 3 by 2. What about the potential? kq by root over r square plus x square. How will the field graph look like? It will increase and decrease, increase and decrease. The value will maximum value will occur at r by root 2. Clear with the results? Especially the finite thing. Remember that finite line ka formula there. What about this thing? Disk and a hemisphere. Find the field at the center and find the field at this point here. Do you guys remember the projected area thing? The Gauss law taught you this thing. The field will be sigma by 2 epsilon into 1 minus cos theta. What about this thing? Sigma by 4 epsilon. And here, if you make theta tending to 90 degrees, it becomes an infinite sheet. The disk will become infinite sheet. The field due to an infinite sheet is sigma by 2 epsilon, constant. Clear with this? So let me ask you a question on this. Let's see whether you guys remember that one. It's a good one, mostly an advanced question, but still. Let's say we got a cube. Hollow charged cube where this is sigma, that is sigma. This is minus sigma, and minus sigma. Basically, three surfaces are sigma and the other three surfaces are minus sigma. Getting it? Find the electric field at the center. So three in a cube, three sides you have plus sigma. The other three sides are, you understood, so I'll not draw that. Okay. Sigma is the surface charge density. Find the electric field at the center of the cube. नहीं रे अंश, infinite plate नहीं है ना. These are finite plates. You cannot apply sigma by 2 epsilon directly. No, it's not zero. Listen. So how do you handle this? Before directly jumping into this, we need to do first this normal one. If you just take a plate, I hope you guys remember this. This was the result. if you take a charge here, plus Q, keep it here, and let's say this is plus sigma. And you can do it only at the center, huh? And if you take this as A by 2. So what is the force on the sheet or the charge? It will be the same thing. The force on the charge will be sigma into flux on the sheet due to the plus Q charge. You guys remember this? This you should check out in Gauss law. Right? I'm not going to the derivation. You can check this out in Gauss law. This was a question. Somewhere here we did. There. Question 8, page 34. Find the force between them, plus Q and minus Q. These things. Check it out in the Gauss law. It is there. So this is the formula there. So this will be sigma. And what will be the flux? If I put 6 more plates on this thing, the flux will be Q by 6 epsilon. Agreed? Now, but what is the force on the charge? Force on the charge is nothing but charge into the field due to the plate. QQ will cancel. Therefore, field at the center will be sigma by 6 epsilon. That is due to one guy. Getting it? Now at the center, you will have field like this. So we have 3 components like this. I'll just call it E, E, and E, and the minus ones also will attract. So that also will be like this. So that is another E, E, and E. Therefore, the field at the center will be sigma by 3 epsilon I cap, J cap, K cap. You want the magnitude, then sigma by root 3 epsilon. This can be an integer equation. They'll give you sigma by root x epsilon, find x. Clear with this. This is a good one. This will go beyond mains, but it's a good one. Clear with the concept? So you can play around like that with flux questions also. There is one more I wanted to ask before going ahead. Suppose if you have a solid, infinite solid cylinder, again, most people don't remember because these are not standard results. Most people don't remember them. Rho and radius r. Find the electric field as function of small r. Infinite solid cylinder. Rho is the charge density and r. Find the electric field as function of r. Same stuff. You can always ask in gravitation. It works. Let's go. Let's go. Don't get tired. You have to sit for 3 hours in the exam like this. Like I said, right? Think of the session like you're sitting and studying with me. Normally, if I leave it on your own, every 15 minutes you will get up and walk around, right? So I'm teaching you not only physics, I'm also teaching you how to sit without getting up. And why do you think I kept the exam in the end? That is when you'll be most tired. There. Finally, I got a chance to become an evil person today. How to do this thing? Gauss law, everyone. Same question I can ask in magnetism also, Ampere's law, if you remember magnetic field inside a solid cylinder. So this is what I'm saying. The moment I give the question, if it doesn't strike what to do within 30 seconds, meaning you have not seen that before, or you don't know how to do. As simple as it'll take time. You should go ahead and go to the next easy question. Consider a Gaussian surface at a small r. Then for r less than equal to r, integral E dot ds is q by epsilon. This will be E into surface area will be 2 pi r L. Remember the field will be radial. So, and what is the charge enclosed rho into cylindrical volume is pi r square L by epsilon. So pi goes off, L goes off, rho r by 2 epsilon. It's a linear function. For r greater than r, if you take a cylinder like this, This will be E into 2 pi R L will be rho into pi capital R square L by epsilon. This will be rho R square by 2 epsilon small r. It's proportional to 1 by R. This is proportional to R. So the graph will kind of look like that solid sphere ka graph only. Clear with this? And you know how they'll frame questions on this? They will frame a question of this sort. They will say there is a interstellar dust getting it this, and it is in the form of a solid cylinder. And assume there is a satellite which is rotating inside this cylindrical dust column at a distance of smaller. Find the time period. Getting it? And then it just becomes simple rotation question. So the force of attraction will be F is equal to mass m into the field is equal to mv square by r, centrifugal force, or m omega square r. And from there you'll get the time period and then you'll solve. Clear with this? So they can frame questions of that sort also. Let's get these two. Particle is projected with u and theta, q and m. There's an electric field, there's a gravity. Easy one, find range, h max, and time of flight. Second thing, pendulum, mass m plus q, gravity is there, and someone switched on the electric field at t is equal to 0. Find the maximum angle deflected and the time period for small oscillations in equilibrium. Any point you didn't understand the question, you should ask. Question is clear, you should go ahead. Cams on, everyone. Keep your cams on. First was easy. If you remember H max formula, this is u vertical square by 2 times a vertical. The electric field is not going to affect anything in the vertical direction. So the H max will remain same, u square sine square theta by 2g. Time of flight is 2 times u vertical by a vertical. Again, the horizontal electric field will not affect in the vertical direction. So to use time of flight will remain same. Range gets affected. So as this particle is flying, it will experience a force EQ. So it will have an horizontal acceleration, which is EQ by m. Then your formula will be Sx is equal to uxt, kinematics ka second equation, half ax t square. Generally, what used to happen, ax used to become 0, so you used to ignore that term. You can't do that anymore. This will be u cos theta, time of flight, plus half ax will be eq by m, time of flight square. Take time of flight and substitute here. Here will be done. So the first term will be a regular range u square sine 2 theta by g. This will be that additional term. Clear with this? What about this pendulum thing? This is a good one. Nee, Advait, the time period will be wrong. Right channel. Yeah. One of the most common mistake here, people think maximum angle is the equilibrium angle. Be careful, maximum angle is not equilibrium angle. It won't stop at equilibrium. At equilibrium, you'll have maximum speed. You will continue to go forward. Unfortunately, that option will be there. And most people will tick that and come. Tan theta is equal to EQ by mg. He didn't say system is in equilibrium. T0, it is vertical. You switched on the field. And that messed up everything. So if you draw the picture, this is how it looks. Somewhere here is your equilibrium. Somewhere here, this is your extreme angle. So here your speed is 0. Here your speed is 0. Here your speed is maximum. This is your mean position. Right? So without actually solving, you can get the answer. If this is theta, this has to be theta, na? Symmetry. And we know tan theta is equal to EQ by mg. So double that theta, you're done, you'll get the answer. But if you want to solve this normally, then the force will be EQ. The force is EQ here. This is the horizontal distance. So work done by external force will be change in potential energy plus change in kinetic energy. Here the external force is EQ. Work done is L into sine theta. That's your horizontal displacement. Change in potential energy mgl into 1 minus cos theta. This will become 2 sine theta by 2 cos theta by 2. 2 sine square theta by 2. So there you get theta max is equal to 2 times tan inverse EQ by mg. Clear with that? And what about the time period in equilibrium? G effective everyone. Hope you remember that concept. So in equilibrium, when it is at rest, so if you ask the pendulum, it will think this is then down direction gravity. Up and down is simply the direction of net force. So if you ask the pendulum what is down, it will think this is down. The direction of net force is down. So if you displace this, it is going to oscillate about this position with small oscillations. And what will be this gravity then? G effective will be root over G square plus EQ by M whole square. That is will be the gravity. So if you ask the pendulum, it will think this is the gravity. And then you're done. So what's the time period then? Time period is 2 pi root over L by G effective. Is that clear, everyone? So the same question, I could have done this with, I can say this thing was placed in a container. Container is accelerating with A. Getting? And container is accelerating up and down. You can play around like this. Any doubts on this? Yeah, right, Yashil. So G effective is quite an important concept. Any doubts on this? All clear? Take a break. Come back by 7:35. We'll continue from here. 10 minutes. Go away from the screen. Watch the sky or something. Wash your face and come back. Once you're back, again we'll do more. Let's get the next one. We have a ring. The upper half is plus q, bottom half is minus q. Find the dipole moment of the system, acceleration of the center of mass, and describe the motion. Exam options will be like it's a oscillatory motion, SHM, something of that sort. Other scams on. So what's the concept here? Replace the entire charge at center of mass. That's the idea in these kind of questions. Why can you do that? Because if you look at this, suppose if I had given you half ring and asked you where is mg acting, you will say mg is acting at center of mass. But technically speaking, the weight is acting dmg, 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 dmg everywhere. Using that same logic, you can say the electric force will also act EDQ, 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 EDQ everywhere. So I can use the same logic and set it at the center of mass. So be careful. This will work only when the electric field is constant. If E is variable, you can't do that. That's the idea in these kind of questions. So for uniform electric fields, you can replace the entire charge at center of mass. So we can call center of charge, but remember, technically there's no concept like that. For uniform electric field, because Emacs doesn't care whether it is G or EQ by M. It is the same thing for Max. We can replace charge at center of mass. So that means you should know center of mass of half ring ka formula. Hope you guys remember center of mass of half ring. If you don't know that, you're gone. That is plus Q. That will be 2R by pi. This is minus Q. That will be 2R by pi. Right? So the dipole moment, so you can replace this whole thing with a dipole. P bar will be Q into 4R by pi into J cap. That's your dipole moment. And next thing what you can do, this will be EQ. This will be EQ. Since it is not slipping, there is a friction on the ground F. And if it is not slipping, you can always take the torque about the bottommost point. That is the safest point. Then we'll get torque about point A is equal to torque due to a couple is independent of axis. So EQ will form a couple, that is EQ into 4R by pi. So I'm asking you at this instant, right? So I can do it after some instant also. So let's say if it has rotated by a theta. This is EQ and this is EQ. Then your torque will be this. I'm doing at an angle. EQ into the distance will be 4R by pi, and the distance will be cos theta. 2R by pi cos theta, 2R by cos theta. That is equal to IA alpha. There you'll get this your angular acceleration. 4EQR by pi. Moment of inertia about A will be, it's a ring, right? mr square plus mr square, 2mr square. So alpha is not constant, alpha is variable here, and these angles are not small angles. So this is not SHM, right? And basically this thing will do an oscillatory motion. So if you actually try to draw the picture there, it would look like this. So this will be plus q. Plus q will come here, plus q will be here, plus q will be here, and plus q will be here. This will be minus q. This will be minus q. This is not writing here. This is minus q. This is minus q. This is minus q. So there. So the motion, it will rotate clockwise, clockwise. This will come to rest. Then it will again rotate anti-clockwise, anti-clockwise. So it will be, the motion would be something like this. If you're looking into my screen, it will be like going front, then coming back, going front, coming back. This is how it will keep on oscillating forever. It's an oscillatory motion. It is not SHM. Clear with this? And they can ask you more actually. They can ask you find the maximum omega. Then what to do? You can integrate omega d omega by d theta and that into cos theta. If you integrate, you'll get omega also. You'll get maximum omega when theta is 90. This is actually, I think I did it. This is omega max actually. Then it slows down and then comes back again. Yeah. You can play around like that. Play with that. Get these things. We have a ring with a non-uniform charge. This was an old PYQ. The total charge is Q and R. Find the electric field due to the ring dot dl from the zero, the center of the ring, to infinity. If you integrate the electric field due to this non-uniform charged ring from the center till infinity, what do you get? If potential is x y square z cube, find the electric field at 1, 1. If this is electric field, find VA minus VB. Let's get them. You have a non-uniform charged ring, total charges Q and radius R. If you are integrating the electric field from the center to infinity, what is the value? That was I think it's a very old PYQ. Get them. You got 2 minutes for all. Hello. నేను క్లాస్ తర్వాత చేయనా నీకు నువ్వు అర్జెంట్గా చేస్తే అర్జెంట్ అనుకున్నాను క్లాస్ తర్వాత First was easy. It looks just weird and all. Ask yourself, what is E dot dl? Potential difference, isn't it? So indirectly, I'm asking you find the potential difference between center of the ring and infinity. What is the potential at infinity? 0. What is the potential at the center of the ring? KQ by R. All are equidistant, right? Even though the ring is non-uniform, all the points are equidistant. So it's simply the potential difference. Just be careful with the sign though. Get the remaining two. Electric field ray, God, these will come in terms of vector form. Don't give in the magnitude. Hope you guys remember partial differentiation. These things can be also asked in work power energy, these two equations. Class will go until mostly 8:45, 8:50. Yeah, we will start the speed test at 9:30. So let's see. So when you see the non-uniform charge, don't get scared of that. Understand the meaning of this. So integral E dot dl minus 0 to infinity. This is actually V infinity minus V center, right? So if you send minus that side, this is E dot dl from 0 to infinity will be V center minus V infinity. V infinity is 0 and V center is kq by r. Even though it is non-uniform, it doesn't matter. Clear with this. And what to do with this guy? Electric field is nothing but minus dou v by dou x I cap, partial differentiation everyone, minus dou v by dou y j cap, minus dou v by dou z k cap. So if I do that partial differentiation, dou v by dou x, so only x is a variable, remaining all are constant, minus y square z cube I cap, minus 2xy z cube j cap, minus 3xy square z square k cap. Now substitute 1, 1, 1, minus I cap, minus 2j cap, minus 3k cap. Clear with this. Don't add 1, 2, 3, and be careful with that minus sign. And what about this guy? VA minus VB minus integral xy square I cap plus x square y j cap dot dr. Dr is nothing but dx I cap and dy j cap. Hope you guys remember, this forms a perfect differential. Xy square dx plus x square y dy. This can be written as minus integral of d of x square y square of integral. There's a name for this kind of differentials. It's called perfect differential. So here this limits will be xa square ya square, which is 1 1, so 1. This is xb square yb square. So you can treat x square y as a one single term, maybe some p or something, and then you can finish it off. That's 4 and 9, that's 36. Yeah, so this limits will be minus half and 36, 35 by 2. This is a perfect differential. You want to know more about this, you should go to Vakparanajika notes. That is the first time we discussed this. Clear with this? All clear? Any doubts on this? And be careful with that VA minus VB, right? So I think I wrote wrong. Wait, I wrote wrong. It's plus actually. Because when you say VA minus VB, the upper limits are XA and X, this thing. This is XA square, YA square. You have to be careful that the signs are important because there'll be two options. One is plus and one is minus. B is your initials, XB square, YB square. Yeah, plus 35 by 2. Clear with that? Because you'll do everything, you'll just goof up that sign and come. It pinches a lot. You know, if you don't know the question, that feels better actually. You know the question and you mess it up, that hurts a lot. Let's get this. A hollow shell, solid sphere, plus QR, minus 2QR. Plot E versus R and V versus R graph. Yeah, this is brute force actually. Out of all, the graphs will be always the toughest ones because you literally have to do everything. If they just ask you find the field here, find the field here, your life will be easy. But when you do graph, you're literally covering everything. go. Let's go. This is little work. Now, if you observe inside, first of all, due to the shell, the field inside the shell is zero. Getting it? The shell will act only outside. Inside, it will behave like a solid sphere ka result only. E inside the shell is zero. Right? And for the solid sphere, what was the formula? We have written this just now, minus gm bar by r cube for r less than r, minus gm by r square for r greater than r. So when you plot the graph, so I'll do one thing. I will use green color for the outer shell and the red one for this, so that it will be easy for us to see. Okay, so for the shell inside, this guy will be 0, this guy will be 0, and just outside will be, it's a minus charge, huh? So minus k 2q by 2r, which is minus kq by r. Great. What about this guy? So inside we have the field here, E inside. Here it is the E outside wala formula, and again E outside ka formula. So great. So inside the field will vary linearly till r. Then it starts decreasing. So the graph will look exactly identical till 2r. At 2r, suddenly things get messed up. At 2r, this field will be kq by 2r. So just on the surface, the field will become, so E at 2r will become minus kq by 2r. Means your graph will suddenly dip to negative category and then it will tend to 0. Making sense? So once you cross that surface, there will be a discontinuity there. The graph will split. Clear with this? At infinity, it becomes 0. So this will be your E versus R graph. So same way, we can play for potential also now. What do you think will happen for the potential? Now, potential inside is not 0. It's actually constant. So for V hollow, the potential inside will be minus k2q by r, 2r, which is minus kq by r. This is for r less than 2r. Minus k2q by small r for r greater than 2r. This is a very important formula, eh? For a solid sphere. Definitely mark it up. Like I keep saying, you mains is not the only exam you'll be writing. This will pop up in some or the other exam. So we have to take the summation of these two. So luckily, if you see, inside it is simply a constant only. So whatever is your the potential, normally it will be how much? 3kq by 2r. This time it will start from 3kq by 2r minus kq by 2r. The graph will start from kq by 2r, but it's still a parabolic graph. And then it will decrease. And on the surface, the potential becomes how much? Minus kq by r plus kq by 2r. It actually goes to negative. and then it will tend to 0. Clear with this? There. So graphs are important. So this will take care of both the formulas, hollow shell and solid sphere. This one. We have two infinite sheets plus sigma minus 2 sigma. Draw the field lines and draw the equipotential surfaces. Three infinite line charges lambda along xyz axis. Find the equation of equipotential surface. This was the PYQ, the B part. C is a HCV equation. A is a good one. Let's get this. We have two infinite sheets, one in xy plane, one in yz plane. Draw the field lines and draw the equipotential surfaces. B, there are three infinite line charges along xyz axis. Find the equation of equipotential surface. C, there are equipotential shells, 60 volt, 10 centimeter, 30, 20. Find the electric field in the region. It's charge minus sign. Ah, right, it's charge now. I got it. Concentric quadrilaterals. Quadrilaterals. Rhombus nahi hai. They form like a diamond. We have done this before. We have done something similar even in magnetism. Let's see the A part. So let's call this thing minus 2 sigma. I'll use green here. So what an infinite plate do? It's an infinite sheet. The fields will be constant. So this will be downward. Let's call it E2. This will be towards the sheet E2. So E2 ka magnitude is 2 sigma by 2 epsilon, which is sigma by epsilon. This also will be E2. This also will be E2. E1 will be sigma by epsilon. Positive thing will push this way. E1, 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 and E1. So basically the magnitude is same everywhere, only the direction. So the field in the second quadrant will be pointing downward. The field in this quadrant is this way, and this way. So if you actually try to plot, this is how the field lines will look like. The directions will be I wrote wrong. Wait, this is this way. This way, they should go towards the negative. Perfect. That is your field lines, everyone. And how will equipotential surfaces be? Equipotential surfaces are always perpendicular to the field lines, remember? If you remember, that is one of the property. The electric field lines are always perpendicular to the equipotential surfaces. So you need to draw perpendicular to this. There, these green lines will be your equipotential surfaces. Clear, everyone? Maybe I should draw it separately, I guess. They look like this. Then what about this infinite line charges thing? Now remember, field due to infinite line charge is 2k lambda by r. So for the potential difference, when you integrate EDR, you end up with something like 2k lambda ln r. You can adjust the limits. Now be careful, what is this r? This r is the perpendicular distance from the wire. It is not your distance from the origin. So if you take potential due to the wire at x-axis, potential due to y, and potential due to z, that must be constant. That's what you want an equipotential surface. So 2k lambda ln. Anyone remember what is the perpendicular distance from x-axis? Perpendicular distance from x-axis is what? Ignore x coordinate, get the remaining two. Root over y square plus z square. 2k lambda ln root over x square plus z square. This thing, first time we encountered this thing in rotational mechanics. Because in moment of inertia mr square, what is r? Perpendicular distance from the axis. This is x square plus y square is equal to constant. Ln terms can be added up, you end up with y square plus z square, x square plus z square into x square plus y square. Options were given like this. X plus y into y plus z into x plus z is constant. This is one of the options. So this is the equation of the surface which is equipotential. So perpendicular distance to x-axis, you ignore the y coordinate. So it's be x square plus z square. Clear with that? This was actually a JEE mains question, and 2022 or 2023 is like 2-3 years back. Field lengths will be straight lines in xz plane. It's an infinite sheet, na? Yashul? This is fine. Yeah. What about the C part? So the P question was really a good one. And the C part, if you realize there is something constant there, potential V into R is constant. V into R is 60 into 0.1 is 6. 30 into 0.2 is 6. So we get V is equal to 6 by R. So field is nothing but minus dou V by dou R. That will come out to be 6 by R square. And we know in the direction of the potential, in the direction of the field, potential decreases. So potential is decreasing 60, 30 and everything. So the field is radial. These kind of things will come due to a point charge. Clear with this?
Could you explain what it is? Yeah,
This one?
that's it. Yeah, this is actually.
Hey, observe, no? If you see in all these three things, right, V into R is always constant. Potential is given 60 volt and 10 centimeter, 30, 20, 20, 30. The product is constant. So we got potential into distance is constant. So we got potential differentiated to get the field. Clear? All clear with this? This is another standard question. Let's get this. Two planets, mass mr. You want to project a rocket from one planet to another planet along the line joint in the centers. Find the minimum speed to reach the other planets. Recently, Ohm goofed up this thing. So Let's get this. It's a very good question. Standard model, but it's a good one. Most people do goof up one place or the other. So just get me the equation sufficient. Don't worry about simplifying. You, as long as you get the main equation done, I think your job's done. And if you have time, you continue solving before I go to the next question. Yeah, write the equation, write the equations. Simplification is fine. Equations are important because I know most people goof up. There are 2 points where you can goof up. Don't say center of mass. That's a wrong statement. Luckily, it works here. If I take m and 4m, then center of mass won't work. I hope you guys remember the concept here. You have to send it till the null point. In this case, since masses are equal, the null point will occur in the center. There is one PYQ like this. A particle is launched from Earth to Moon. How does the weight of the person vary with the distance? Something of that sort. So same thing, if I try to plot this, see what happens. When you're here, you're attracted by the left side planet. As you're going towards the right side, both the planets are attracting, but in the opposite direction. So the person's weight will keep on decreasing. When exactly this person is at the center, you will feel weightlessness. Meaning if I just drop you here, you'll feel weightlessness. So if I can send you somehow till that point and then just push you little, then automatically you will go and fall on the other planet, right? You're getting it. So your initial and final state, some people think like this. They think this is initial state and this is final state. No, that is not your final state. You need to send it till the null point. After that, a little push and you automatically go. If you see in terms of chemistry, let's say if you're undergoing a reaction where the reaction curve is like this. This is the reactants and this is the products. Since reactants and products are at same energy, does it mean you don't need to give any energy for the reaction? You still have to provide activation energy now. You need to reach the peak, then automatically reaction will proceed. So that is a catch here. So we need to send it till the null point. So if the particle reaches the null point, right, and the other planet will attract it towards it. So you need not give energy after that, it goes off automatically. So if the masses are not equal, it will not be center. So this is your state 2 and this is state 1. Till here people realize also. Then people go up here. Energy in state 1 is equal to energy in state 2. What is energy in state 1? Potential energy. Due to what? Due to both the planets. Minus gm by r, that is the potential on the surface, minus gm by 9r. That is the potential of this planet at this point. Hope you have written that. That is one of the most goofed up things. People forget that. That's it. That is the only mistake normally. Or else people generally get this. Of mu square is equal to, at the center, the potential will be minus gm by 5r into m. 2 times. Done. Solve this, you'll get the u minimum. Clear? So these are the 2 points. You have to take the potential due to both the planets and you have to take the till the null point only, not to the other side. Standard question, good one. Do remember this. Things will keep popping up. And last 5-6 years, the mains questions we are seeing, right? Questions do repeat. At least 4 or 5 questions you must have seen direct questions from the previous PYQs. That will save you time. Let's get these 3. We have a solid sphere with a cavity. So O and O dash are O dash is the center of the cavity, O is the center of the sphere, and A is a point inside the cavity. Distances are given. OO dash is 3r by 4, AO dash is r by 8. Find the electric field at point A. We have a hollow hemisphere plus Q. Find the direction of the field at point A. A is somewhere here. That's a good theoretical question. We have an infinite half hollow cylinder. Find the electric flux passing through the base. Let's get them. Hope you guys remember that result, field inside a cavity. Quite an important one. A simple question would be like that, if there is a cavity, how does the field inside vary? And there'll be options. The field will increase linearly, field will remain constant, field is in this direction, field is in that direction. If a particle is thrown inside the cavity, what kind of, which path does it take? It can go in a straight line, it will go in a hyperbola, parabola, circle. So there'll be options of that sort. So they can play a lot. That's what I'm saying. The moment it's a cavity, and if you don't remember the result, you're gone. That is how you get speed in the exam. Most people think, sir, I'm slow in the exam. The reason you're slow is because you have not seen that question before. Again, I'm not talking about advanced. Advanced, alag story. You get ample of time and the questions are tough and you need not do everything. Advanced paper, if you solve even 75% of the paper and you get 60% marks, you're still in. Mains mein you need to score 90 plus out of 100 in physics. Not because I'm a physics teacher. It is because the paper is easy. The only two scoring subjects are physics and chemistry. Every year, maths is coming so tough, right? Even last year, physics was slightly more moderate. It was not that easy also. Maths was coming tough. And I told you this. Physics may people who scored 90 in one of the paper out of 100, they got a percentile of 99. What is the meaning of that? One percentile is roughly around 10,000 kids, or like, I think if it is one slot, around 3,000-4,000 kids. In one slot, 3,000 to 4,000 kids got 90 plus in physics only. In that same paper, max, people who got 36 out of 100 got 99 percentile. Paper was tough, but end of the day, tell me one thing: your total rank will your rank will depend on what score? Total score, right? Now, what is the point, right? You do max really well, right? Score 50 or score maybe 60, which will put you at 99.99 percentile in max. And physics, you goof up and you do 70, right? You're done, right? The others are going to cross you here. You're getting the problem. End of the day, total score matters. So physics, chemistry, max, right? People who are struggling here to get 180, you should focus primarily on physics and chemistry. You should push it to 85, 85, and max whatever is that. If you're already crossing 200, then you should maintain, physics 90, chemistry 90, and then max how much ever you can push. Your math, physics, and chemistry are the two scoring things in mains. If the paper comes like last 5 years, because I'll tell you, last year even some of the medical students have scored 95 in physics, and it happens every year. Generally, in the last 5 years, last year was my last medical batch. In last 5 years, at least 4 times, medical people scored more than NEET JEE people. Two reasons: one, they don't need to do maths, so they spend 1.5 hours on physics only. And second, they're more relaxed. It is not their exam, they just come for a picnic. So they actually do the mains ka physics paper well, and NEET ka physics paper they go up and come. If you see some PYQs, right, or last year papers, you must have realized, isn't it? Physics was sometimes it feels very hopeless paper. You should solve some old JEE mains papers and see. 1 or 2 papers, don't do more. It gives you a very false confidence. So How does the field vary here? I hope you remember the result. E is equal to rho by 3 epsilon O dash bar. It depends only on the distance between the centers. It doesn't matter where is point A. So this was rho by 3 epsilon 3r by 4. That's your magnitude. And what is the direction? The direction is like this. The field inside is uniform. So this is O dash cap. It's a constant field, everyone. So it doesn't matter where is point A. So if you throw a particle inside, there are only two possibilities. Either you will go in a straight line if you throw along the field, or if you throw at an angle, you'll go in a projectile motion. Clear? So if a particle thrown inside a cavity will either go in a projectile or a straight line, depending on how you're throwing, at what angle. So that will be a question in advance. You throw from here, it will go and land here. And they will play around with that. Anyways, that is one. What about the second one? The B question is a good one. So if you take full two half spheres, and when you combine them, total field must come out to be zero. So at point A, the field must be Ex, Ey, Ey, and Ex. So when you combine them, you get a full sphere. Ey and Ey will cancel. This will become 2Ex. But we know field inside the sphere is zero. Therefore, Ex is zero. That means when you take a hollow hemisphere, which is charged, the field on all the points here will be downward only. We don't know the magnitude, but the direction is always downward. Play with this. So it doesn't matter where is the point A on that disk, the field will be always downward. What about C? You have a infinitely long hollow hemisphere, cylinder. Find the electric flux passing through the base. Now, if you take any one ring there, you will notice if you join the two corners, this will always form 90 degrees. So if you take a small dq charge, the field lines, what will happen? 1/4 of the field lines will pass between this region, isn't it? Making sense? Because think of it like this. Since it is an infinite cylinder, I can treat each one like an infinite line charge. And for an infinite line charge, the field lines are going which way? Radially. So if you take infinite line charge, the field lines are going like this. They're going in one plane. Clear with this? This is your dq basically, a line charge. Are you clear with that? So in 360 degrees, you will give how much flux? dq by epsilon. In 90 degrees, you will give how much flux? So 1/4 of the lines will pass through the base. Therefore, flux passing through the base is simply q by 4 epsilon. Clear with that? Making sense? Because it's infinite. If it's finite, you couldn't have done that. This one, you can do this thing. We have done one question before. You know how to do that. Take a element, integrate, and get this done. So I'll not do that. Let's get this thing. We have a cube and we have an infinite line charge passing through the corner. Find the flux through each face. B is a standard equation. C, we have a conductor with a cavity. There's a minus q outside. Find the force on the plus q due to the conductor and draw the field lines approximately. I want the flux through each face. Near Navia. There will be 4 faces with 0. Any face which touches the line charge will have field lines parallel to the surface. If it is a point charge, you would have got 3 faces 0. Think. I'll give 2 minutes for all these 3. 2-3 minutes. Let's get them. Find the flux passing through each face. 1, 2, 3, 4, 5, 6. Let's see the first one. Now, if you look at this infinite line charge, look at the field lines, how they go. The field lines will be like this. The field lines will be like this. Getting it? And the field lines will be something like this. So basically, whichever surface touches the infinite line charge, the field lines become parallel to the surface. If this was the infinite line charge and this was the surface, there. So surfaces touching the line charge have E bar parallel to the surface. That is, E is perpendicular to the area vector. Therefore, in this case, flux in 1, 3, 4, 6 is that side, 5 is this side, 5 is 0. Now, how to get the whole flux? Consider another 4 more cubes. Place 3 more cubes in the middle. So if you put 3 more cubes, the whole picture will look something of this sort. Your line will be going from here. And this is 1 cube here. So the flux through the total will be, this length is L, lambda L by epsilon. So flux through each cube. So each cube will share 1/4 of it, lambda L by 4 epsilon. This will be shared between 2 and 6 again. Flux in 2 and 6 is equal. That will become half of the total flux, lambda L by 4 epsilon. Clear with that? Any doubts on this? Great. What about these two? This is straightforward. You definitely should remember this formula. This angle will be 60 degrees. Here, the formula is this. So flux will be the total flux, which is Q by epsilon by 1 minus, if you remember that area ka formula there, this area comes out to be 2 pi r square 1 minus cos theta. And you get total flux Q by epsilon for an area of 4 pi r square. Then what will be the flux for that shaded area? Check out in Gauss law, we have done this. So we get flux is equal to Q by 2 epsilon 1 minus cos 60. Q by 4 epsilon. That's the flux passing through the disk. And what about this guy? Find the force on plus Q due to the conductor. So how will the field lines be there in the first place? So let this be minus Q. Now be careful, there are two distributions here. There is a uniform distribution here. That will be minus Q. And there will be one more uniform distribution here. That is plus Q. On top of it, right, we also have, I think, let me show it in the next page. This is more complex. We have plus Q here. So what will this do? This will induce charges. There'll be two induced charges here actually. You can split this into two parts. This plus Q inside will induce a uniform charge distribution minus Q. And because the outside shell is neutral, you'll also induce a plus Q on the outside surface. All this will be uniform because the charge is exactly in the center. Great. Plus, now forget about the inside one, look at the outside one. This outside charge minus Q will not keep quiet. That will induce a non-uniform charge plus small q, and it will induce another non-uniform charge on the other side, which is minus q. So in total, the outside will be 0. So force is being asked on what? Plus q. Great. Now look at this thing here. This is important, shielding effect. That means the field lines from the outside will never enter inside. So if I try to draw the field lines, this is how the field lines will be. The field lines will enter the surface perpendicularly. Why? Equipotential surface. Conductors are all equipotential. Why? Because field inside is 0. Why field is 0? If there is a field inside the conductor, the charges will start moving in such a way, right? The induced charges will increase till the field becomes 0. And we have proved why field is 0. That means this charge plus q here does not know what is happening outside. This was one of the question in the exam. Huh? If I move minus q outside, what happens to the force on plus q inside? Nothing happens. This is called shielding effect because not a single field line from outside is entering inside. You're getting it? So any charge inside the cavity is unaffected by the outside charges. Now be careful here. Huh? If I ask you this question, is minus q not attracting plus q? Yes, it is attracting. Is the induced charges, this small q and minus small q, not attracting plus q? They are attracting, but together it is 0. Are you getting it? Together they don't interact with anyone. So the force on minus q and plus q plus force on that minus small q plus small q and plus q total is 0. I hope that is making sense. The outside charge and the induced charges together, these three together will not interact with anyone inside. Individually, they are interacting with each other. I hope you're clear with that. So that itself is another question. Why is the force due to the induced charges? That means the force due to the induced charges, which is minus small q and plus small q, will be minus of force between capital Q and minus q. And that we can calculate. Because the distance between them is d, the force is how much? Kq by d square. Now the question starts. Now what was the question? The force due to minus q plus q on plus q will be minus of this, that will be attracting. So kq square by d square I cap. That is the force between the induced charges on this. Great. So what was the question? Find the force due to the conductor on plus Q. Now, when you say conductor, understand there are multiple charge distributions. We have one charge inside, which is uniform minus Q. We have one charge outside, which is also plus Q uniform. And then we have one charge here, non-uniform, which is plus Q, and another non-uniform minus Q. Remember? So you want to find the force due to these three on plus Q. This will be 0 because field inside the hollow shell is 0. This is 0. Field inside the hollow shell is 0. This thing just now we proved. The force will be kq square by d square I cap. Clear with that? That will be the answer. Sure with this?
So why do we have third diagram actually to understand
Why do we have?
the third diagram plus Q and minus Q, the small q
Because
ones?
outside there are two distributions, right? There is a plus q cut distribution and the plus q minus q also. If I ask you what is the total charge distribution on the outside, how does it look? It is a summation of this plus q uniform and this non-uniform, isn't it?
But the overall conductor is neutral.
Fine, but so do you mean to say the plus q and minus q will not interact with plus q because it is neutral?
No, I'm saying that first we induce plus Q charge in the outer shell, out of it, and minus Q in the inner shell of it. So
No. You're
net
just
charge.
lucky there. That's it. What if I just put the charge plus q away from the center? Do you still think it is valid? If it is not in the center, then what do you think will be the charge distribution? This guy will become non-uniform, right? You're getting it? If you don't place it in the center, how will the insert charge distribution look like? If I keep plus q here, what do you think will happen? You'll get more minus here, and you'll get less minus here. So then there will be a force due to this also, no? You're getting it? This will be still 0 because outside will be still uniform. Are you clear? Confused? Let's discuss after the class. If you're still confused, stay back after the class. Let's get this. This is another good one. This is kind of capacitors ka question, but let's do it. Inner shell, outer shell, plus Q, 2Q. The inner shell is grounded. Find the charges and the heat produced. That's a Gauss-Locker question is good one. Huh? It took time, but if you remember, that whole chapter was like that. It was all theoretical only. It was all discussions only, like, because this happened, that happened. We just played the whole thing like that. Get the charge distribution. That itself is a decent question. So hope you remember, whenever you ground something, charge is not conserved, but potential becomes 0. So if this is plus Q, you will induce a minus Q, and you will induce a plus Q. So outside becomes 3Q. Now, when you ground something, don't say charge is 0. That's a blunder. Potential becomes 0. Unfortunately, right? People remember it as, whenever you ground something, charge becomes 0. Not true. Let this charge be small q because it is not conserved anymore. This is minus q. This guy will be 2q plus q. Now find the potential at this point. So potential at A will be kq by r plus k. Total charge on the outer shell is 2q plus q minus q by 2r equal to 0. Q goes off, we get q is equal to minus q. There, the charge is actually minus q now. Then what? This is 3q. This is minus q. This is plus q. And this is q. So now to find heat produced, you can do it normally, but it becomes too much actually. You have to do 3 self energies, interaction energy, interaction energy, interaction energy. Total you'll get 6 terms, becomes complex. But if you treat this as a capacitor C1 and C2, what's a capacitor? It's a space between two plates, isn't it? So field lines are going from inside to here. Do you guys remember the spherical capacitor formula? 4 pi epsilon R1 R2 by R2 minus R1. For a single shell capacitor, what is the formula? 4 pi epsilon R. So spherical capacitor formula we have to use. Spherical capacitor formula was directly asked in the exam once. 4 pi epsilon R1 R2, that will be R into 2R by 2R minus R. In this case, both will come same actually. C2 will be a capacitor between 2R and infinity. 4 pi epsilon 2R. Perfect. So what is the initial energy of the system? On C1 capacitor, charge is Q square by 2C1, energy in a capacitor. On this capacitor, it is 3Q square by 2C2. What is the final energy? Q square by 2C1 and Q square by 2C2. And what is the heat produced? U final minus U initial, or U initial minus U final. There. If you do with capacitors, it becomes much faster. Clear with this? Got this? First of all, you should know how to find the charges when it is grounded. That itself is a very good question. Heat, they might not ask you at a mains level, but yeah. Let's get these two. Parallel plates. It's completely fine if you forgot, you're forgetting things, forgot all this stuff. But at least now you know what you forgot. Go back and revise. That's what you have to do tomorrow. Spend some maybe half an hour, 1 hour, and sit with the notes and revise whatever you forgot. And go and fill up the tracker. The biggest problem is that people don't realize what they forgot also. If you know what you forgot, then you can revise. Let's see. So hope you remember the results for this. Again, you should know the results, how to do this thing, or else you won't be able to handle. So let me show you the results. First thing, whenever You have parallel plates. There are two results primarily. One, the charge outside is how much? Total by 2. And second result, if this distance is d1 and this distance is d2, again we did this in Gauss law, and this is q1 and this is q2. q1 into d1 is equal to q2 into d2. That result you need to know. Without that result, you can't go ahead. And then you're done. So once you close the switch, the outside charge will be q total by 2. Q total will be 2q, that will be q, and this will be q. Let this be x. So x into d must be equal to this. So this must be x by 2. Then this will be minus x, and this will be minus x by 2. So in the middle plate, charge is conserved. So 3x by 2 must be equal to minus 2q. X is equal to minus 4q by 3. Clear with that? What about the second one? That's easy. I can also ask you the heat produced. Then we'll use self energy. Do you guys remember self energy ka formula? For a hollow shell, kq square by 2r. Solid sphere, 3kq square by 5r. So how do you do this thing? So the moment you close the switch, what happens? The potential becomes same. And the charge is conserved. So let charge q flow from here, because sometimes they'll ask you how much charge flows through the switch. This will be q minus q, and this will be minus 3q plus q. Then you're done. So this is kq minus q by r must be equal to k minus 3q plus q by 2r. Equate them, you'll get q ka value, and you're done. Clear with that? That's another standard question there. This we can do something better. Let's do two more questions and we'll take a break then. Let's say electric field is 3x square plus 3x square I cap plus 2j cap plus 4z k cap. This is x, this is y, and this is z. This is origin, and the x coordinate is 1, 0, 0, and the y coordinate is 0, 2, 0. Z is 0, 0, 3. It's a cuboid. Huh? Find the flux in the cube. Find the charge in the cube. We have a dipole P1, we have a dipole P2, and the distance is r. Let the mass be m and mass is 2m. Find the speeds when they separate to infinity. Last two. In case you're feeling exhausted and tired, remember this is how it will feel in the 3-hour exam. Na? Last 10-15 minutes. How do you do that 18th one? We did this thing in Gauss law in a different way, if you remember. I think I gave you potential and then asked you to calculate. Listen, consider a small cube. Now, let's say if you take the field here, let the field be Ex. Then here the field will be Ex plus Dex. So field is varying, right? For a small distance dx. So which area should you take? You should take this area, which is dy into dz. So flux only due to the x ka field, flux only due to Ex will be Ex plus Dex area minus Ex into area. Ex ka term will cancel. You end up with Dex and area will be dy dz. This is the flux inside that small cube, right? Due to this thing, dx and dy and dz. So what is the total flux through a small cube? Dex, dy, dz plus, similarly, I can do dey, dx, dz plus dez, dx and dy. This is the flux passing through a small cube. Clear with this? So dex is a differential of this thing. Huh? So this guy was ex. This is ex. This is ey. And this is ez. So if I substitute here, what is dex? That is 6x dx, dy, dz. Dey is 0 because ey is constant. Dez is 4dz, dx and dy. If you add this up, you can't add it up because there is a 6x there. So flux through the cube will be, it's a triple integration, everyone. 6 integral x dx, integral dy, integral dz plus 4 integral dx, integral dy, integral dz. X ka limits 0 to 1 because x is going from 0 to 1. Y ka limit 0 to 2, 0 to 3. 0 to 1, 0 to 2, 0 to 3. This you can integrate. This will be 6, 1, 2, 3 plus 4, 1, 2, 3. That is 6 to 12, 3, 36. 36 and how much is this? 3 to 6, 24. 36, 24, 60. This must be equal to Q by epsilon. Therefore, charge inside the cube is 60 epsilon. Clear with this? That's how you find the flux for this thing. If you remember in the class notes, we did the charge inside a sphere. And there the terms got added up. That was a more easier one. What about this one? Two dipoles P1, P2 at a distance r, m and 2m. Find the speeds when they separate to infinity. X square, it is dex, na? Wait, yeah, I am got your point. It is x dx, na? X square by 2. So half aega wo. See, this is the hopeless thing. After doing everything, you mess up a calculation. How much is that? 18 plus 6, 4, 24. 18, 24, 34, 8. 42. Hope that looks right. P1, P2 are the dipole moments. These are dipoles. I forgot to tell you, I guess. So we have two dipoles, P1, P2, at a distance r between them. Due to repulsion, they'll fly away to infinity. Find the speeds when they repel to infinity. So when they fly off to infinity, P1, P2, conservation of momentum, there's no external force. You can guess if this speed is 2v, this speed will be v. What is the initial potential energy? That is the actual catch. You guys remember potential energy to dipoles? 3k P1 P2 by r cube. याद है formula? Force between dipoles will be 3 नहीं है 2. 2k P1 P2 by r cube. Force will be du by dr. You'll get 6k P1 P2 by r power 4. Kinetic energy 0. Potential energy 0. Kinetic energy will be half m 2v whole square and half m 2m v square. This thing we did recently in magnetism also. Remember, force between dipoles, potential energy between two dipoles. Check kar lena if you forgot that. Then you're done. Just conserve the energy there. Every time they won't give you charges only. They can give you dipoles also. कितना था ये? 3mv square. There, from there you get the speeds. Clear with us? There. So we did some decent number of questions. We must have done at least, even though it shows 18, we must have done 2-3 questions and everything. So that is few more. Maybe next class when we catch up, we will do few more and then we'll go ahead. Now we will have a break for half an hour, right? Come back by maybe 9:25 or something. Now listen, after coming back, right, you do this thing. Take a paper, take a A4 sheet, take a rough paper, don't waste an A4 sheet, and just write your numbers, okay? 1, 2, 3, so on till 90. There'll be 90 questions, right? Write the numbers till 90, because while writing the exam, you will waste your time writing the numbers 2, A, 3, C, and all that. So keep the paper ready for you. So 9:25 you will come. So I will put the paper in the group, download the paper. So there's a 3-4 minutes buffer time. The exam actually starts at 9:30, right? So since I'm a very good person today, I'm giving you 5 minutes more for 90 questions, 1 hour 5 minutes. So it'll be fine. Don't worry about that, right? You will write, you will get the hang of it. After 4 or 5 exams, you guys will touch 80 also. Happens every year. First exam is always scary. Getting it? So make the paper ready. So this is the process. I'll send you the PDF. You download it on your computer and you'll keep all your screens on. I'll be watching you, right? I'll be giving you time every 5-10 minutes. I'll keep a reminder so that you're not stuck with one question. And your job is to do as many questions as possible. Don't get stuck. Think of like this. There are 90 questions. There are enough easy questions. You just need to find them. There is no need to get stuck at one question and spend 2 minutes on a question. It is a waste of time. So you will learn all that stuff, right? So come back by 9:25. I will shut down the thing. Again, join on the same link. So go have your dinner. If you're really tired, I will seriously tell you, just close your eyes for 10 minutes and just sleep. Just put your head down and just close your eyes for 10 minutes. It helps. Okay, I wanted to give the exam with full energy. So come back by 9:25. So any doubts so far, you can stay back. Others, you can go and take a break.